When we're asked to perform a rotation, there are three pieces of information that we need, which have been given here. The first piece of information is the size of the rotation, so how far we're going to rotate, 90 degrees in this example. We also need the direction of the rotation. That's the minus sign there, which I will come back to in just a little bit. And we also need the center of the rotation. So that's 6, 5 there. So the center, let me mark this on here, 6, 5, just there. The center is the point that the rotation is happening around. If you imagine that this triangle was sitting on a disc or a roundabout or something like that and moving around, the center of that disc would be at this point 6, 5. So we've got that to start off with. Now we can think about actually what this rotation is going to look like. We know it's 90 degrees, so that's a quarter of a turn. So moving around something like that. So scrap so moving around something like that because that doesn't mean anything. And start again with this. And then the other key piece of information there is the direction, because our quarter turn can either go in a clockwise direction or it could go in a counterclockwise direction. And sometimes you'll see the instruction for the rotation written with just those words, clockwise and counterclockwise. But what I wanted to do here was show you this formal piece of mathematical notation. Let's just move that little circle there. So it says negative 90 degrees. And the thing that we need to know for this, if you see this coming up, is that clockwise as a motion, which looks like that, we're going in that direction, that's a negative rotation. Okay, so that would be, in this case, is minus 90 is clockwise. That means then in reverse, counterclockwise, let's write that correctly, counter, I was going to write that, counterclockwise, counterclockwise rotation, which would be around that way, is a positive rotation. So if we'd just been given 90 degrees there, then that would be counterclockwise. That would be moving anti-clockwise. So with that in mind, knowing that this is going to be going a 90-degree turn, a quarter turn, it's going to be going clockwise because it's negative, and it's going to be going around this point, we can now have a go at constructing it. So thinking about doing that, as with our other transformations, we want to think about some construction lines. And our construction lines will connect the center of our rotation to each of our points on the shape. And then we're going to use those lines to more easily visualize how this rotation is happening. So what I mean to say by that is if I connected, say, B with this center of rotation, and then what I can do is I can imagine that rather than trying to figure out how this shape is going to rotate, which can be a little bit awkward, I can try and imagine how this straight line will move around. And I know it's going to do something like a 90-degree rotation. It's going to end up somewhere like this, isn't it? So it's moved around through 90 degrees. Having said that, this is still not the easiest way that we can do it, certainly not for the sort of problems you're going to encounter at this level, because we're trying to work with diagonal lines and we've got to try and figure out exactly how those diagonals are rotating. So instead of using a direct construction line from each point to the center, we can work with little L shapes, which I find quite helpful. So connecting up B, if I, instead of going in a diagonal straight to the center, I follow a little L shape like that, it's a lot easier now for me to imagine how that L shape is rotating. So I can look at the long part of the L, and knowing that's going to rotate round, it will end up pointing straight upwards after a 90 degrees rotation. And it's 5 long, isn't it? So it does that. And then this part of the L here has obviously got to come off the end of that L shape just as it did before, coming 2 out. And we can see then, hopefully quite clearly, that that original L shape has rotated 90 degrees to this new point here. Having done that, let's just mark on our new point. Remember, that's called B prime. So doing it that way is a lot more straightforward to working with our L shapes. The only slight issue we have is being careful when we start getting a little bit cluttered with this whole thing. So I am going to, there's a couple of ways that I could try drawing this L shape out for A, but rather than going straight up, which will just go over the one that I've done for B, I'm going to come out this way first of all, so one out to the right, and then, ooh, let's try that again. My line disappeared. And then I'm going to go straight up from there to A. Having done that then, now I can see that if I rotate this 90 degrees, that little point coming out here is going to end up pointing straight down. And then following around the rest of that shape, it's got to come out this way, hasn't it? And it's 6 by the looks of it. It went up originally. And that's going to get us to our new point A prime over here. Drawing in the rest of the shape for C now then, this is now going to get a little bit trickier in terms of doing these L shapes. So actually for this one, I am going to leave it because I think that's just going to confuse the issue on this particular diagram. You should try and do it just to make sure that you can confirm that you've got it right, but you'll find it easier with pencil because we're able to do them, your construction lines, at different weights and different thicknesses. You'll be able to see a little bit more clearly what's going on. But I can tell you that our point C, imagining this rotating round, has got to end up being up here. So if I write that in, and then I can join these points up and get myself something that looks like that. And now we can see from our original shape, that's been rotated 90 degrees. It's been rotated clockwise, a negative rotation, and we can see it's moving around this central point here.